Okay, so let's unpack this. Let's talk about CodeCraft Studios.
Yeah.
Before they got into all this automation, things were, well, a bit chaotic, maybe.
Oh, definitely chaotic. You hear stories like picture pull requests just landing with titles like stuff, or, maybe the optimistic fix.
Right. And there's that video example, the PR called Various Improvements.
Sounds helpful, right?
Not so much. Apparently, Sarah on back end and Jamie on front end were just completely lost. 8 files changed across 4 different services. What were the improvements?
Total confusion.
Yeah.
And meanwhile, you've got critical bugs just slipping through, CI failures happening, but nobody notices them in all the noise.
And teams doing the same work twice because, information silos. Nobody knows what the other team just fixed or built.
Does any of that sound familiar to you listening? I bet it does.
It's a classic problem, unfortunately.
Yeah.
And that's really the core issue we're diving into today, isn't it? How do you, the listener, cut through all that information overload? How do you bring some intelligent automation into these really complex developer workflows? Exactly. So our mission here for this deep dive is to walk through this CodeCraft Studios case study. They used Hugging Face's Model Communication Protocol MCP to build a custom workflow server for Claude code specifically.
And the goal is pretty big. Transform that chaos into clarity. Make things efficient, make them smart.
Yeah. So we're going to follow their journey, like step by step. We'll look at how they use the core MCP building blocks, tools, resources, and prompts, and crucially, how they all fit together.
Right. And the obvious place for CodeCraft to start was, well, the daily pain, those pull requests.
Uh-huh.
You know how it is. Developers are under pressure, shipping code, writing a really detailed PR description. That often falls pretty low on the priority list.
Which leaves the reviewers stuck, wading through those various improvements across, like you said, 8 files and 4 services. It's just a huge waste of time.
It really is. So the very first step CodeCraft took, the foundational piece, was building a basic MCP server. They used fast MCP, and the key concept right out of the gate was tools.
Tools. Okay, so tools are like how Claude code can actually do things, interact with the outside world.
Exactly. Execute functions, get data, call an API, that kind of thing. For this PR problem, they built a few specific ones. First, they needed Claude to know what was in the PR.
Makes sense.
So an analyze field changes tool. This thing could go fetch the raw git diff, get the list of changed files, pull some stats on the changes, the basics.
Yeah, the raw data.
Then they needed to know what kind of PR it was supposed to be. So a get per templates tool. This just listed out the available templates a team used: bug fix, new feature, docs update, refactoring, whatever.
Got it. So you've got the code changes, you've got the template options.
There's not a magic piece. A suggest template tool. This let Claude take the analysis from analyze field changes, look at the actual code modifications, and then intelligently recommend the right template from the list.
Okay. So Claude does the heavy lifting of figuring out if it looks more like a feature or a bug fix based on the code itself.
Precisely. And this shows a really fundamental idea behind MCP that came out in this case study. Instead of developers trying to write brittle, hard-coded rules like, if the file path contains fix, then suggest the bug template.
Which breaks the minute someone names something slightly differently.
Exactly. You don't do that. You give Claude the rich, raw data, the full git diff, and you let Claude's intelligence analyze that data and make the smart decision about the template. It's way more flexible, way more adaptable.
It makes a lot of sense. But the sources mentioned, they quickly realized just the diff wasn't always enough, right? The suggestions needed more context.
Yeah, context is key. A change might look like a feature, but maybe it violates a team coding standard or doesn't fit the project architecture. That's where resources come in.
Okay, resources. Different from tools.
Yeah, resources are read-only context. Think of them as information Claude can look up. Stuff like file.templates to see the actual content of the PR templates, or file.project context where coding standards, review guidelines, architecture docs might live.
So like the project's rulebook.
Kind of, yeah. They even use things like git.recentChanges so Claude could see recent commit patterns, or team.guidelines for specific team practices. Claude uses these resources alongside the data from the tools, like the diff.
So it's not just analyzing the code in isolation. It's analyzing it within the context of how this specific team works on this specific project.
Exactly. That leads to much smarter, more relevant suggestions. Truly context-aware.
Okay, now, this is where, according to the documentation you shared, things got really interesting. They hit a wall, a technical limitation.
Oh, yeah. The big one. The 25,000 token limit for tool responses?
25,000 tokens.
Yeah.
That sounds like a lot.
It does, until you run into a big, complex pull request in a large enterprise code base, or maybe a massive refactoring. The git diff alone can easily be thousands and thousands of lines.
Wow.
And then you have to wrap that text in JSON to send it back to Claude, which adds even more characters, more tokens. You can blow past that 25K limit surprisingly easily. It's something you absolutely have to plan for in production MCP.
So you can't just dump the entire diff into the tool response every time.
Not reliably, no. The solution they figured out was designing the tools with output limiting. Smart design.
Meaning?
For that analyze file changes tool, they added parameters, maybe a max defined setting. Or, perhaps even smarter, the tool first provides just a summary like the output of git diff stat, and Claude can then specifically ask for the full diff of certain files if it needs more detail.
Be tactical about the data. Don't send everything unless asked.
Exactly. It's a crucial pattern.
And there was another practical hurdle they hit early on, right? Something about where the commands actually run, working directories?
Ah, yes. The working directory consideration. By default, your MCP server code runs wherever it's installed. But Claude Code, the user interface, is probably running with the repository root as its current directory.
So if your tool just runs git diff,
Yeah.
it runs it in the wrong place, not on the user's code.
Precisely. Total confusion. The fix uses something called MCP roots. Claude Code automatically tells your server about the user's working directory as a root. So in your tools code, you call context.session.listroots. Find the right directory path for the user's project, and then when you run your git command using PyCon subprocess, you pass that path to the kurbood parameter current working directory.
So you explicitly tell Git where to run.
Exactly. Ensures your tools operate on the correct code repository. Another one of those essential practical details.
All right, so foundation laid, they're tackling PR chaos, learning about token limits, working directories, but PRs are just one part. The case study then pivots to the next big problem, those silent CI/CD failures.
The silent killers. Like that story you mentioned, the payment system bug. CI failed on Tuesday, red X somewhere in GitHub Actions. Nobody noticed until Friday afternoon when things started breaking for real.
Nightmare scenario. And you can't just sit there hitting refresh on dozens of GitHub Actions pages all day. It doesn't scale.
Not at all. So the solution was to extend their MCP system to get real-time awareness using webhooks.
Webhooks. Okay, so GitHub sending notifications to their system.
That's the idea. The architecture they used was clever. They ran a separate, small webhook server, maybe on port 8080, alongside the main MCP server on its usual port.
A separate process. Why?
Separation of concerns. The webhook server's only job is to listen for those incoming HTTP requests from GitHub events like workflow run, check run, whatever, and just log them. Simply write the raw event data to a file, like github events.json.
So the webhook server doesn't do any analysis, it just catches the ball.
Exactly. It just catches and logs. Then the MCP server reads from that log file. This keeps the MCP server focused on analysis and avoids burdening it with handling raw HTTP traffic directly. Much cleaner.
That makes a lot of sense. Okay, so now they have this stream of events flowing into a file. How does Claude access it? New tools.
Yep, new tools. They built things like getTree sentactions events. Its job. Read the latest entries from that github events.json file. Simple.
And maybe something makes sense of the raw events.
Right, like a get workflow status tool. This one knows how to parse the event data, filter for the important workflow run events, maybe group them by workflow name, and report the latest status success, failure, in progress.
Okay, tools to get the CI data. Now, the case study brings in another core MCP concept here. Prompts. How are they different from tools?
Good question. The way the material describes them, prompts are more like user-initiated templates or workflows. Tools are things Claude calls on its own, behind the scenes, to answer your request or gather data. Prompts are things you, the user, explicitly trigger. You might have a prompt name analyze latest CI results. When you invoke it, it guides Claude through a predefined standardized process using the available tools to fetch the data, analyze it, and present it consistently.
So prompts provide structure for common tasks, like generating a deployment summary or maybe guiding Claude through troubleshooting steps for a failure.
Exactly that. They bring consistency and reliability to how you interact with Claude for specific recurring workflows.
That's powerful. Now, practically speaking, how did they test this? Getting GitHub webhooks to hit your local development machine sounds tricky.
It can be. They used a tool called Cloudflare Tunnel, specifically the Cloudflared command line utility.
Ah, Cloudflared. I've heard of that.
Yeah, it's great. You run it, and it takes a service running locally like their webhook server on port 8080 and creates a secure tunnel, giving it a temporary public URL.
So GitHub can actually send real events directly to their laptop for testing.
Precisely. Makes development and debugging so much easier than constantly deploying changes just to test the webhook receiver.
Okay, connecting this back to you, the listener. Think about what this changes. Claude goes from being this static tool you ask questions of to being a dynamic monitoring system.
Right. It's now proactively aware of your build and deployment statuses. It can flag those red X's immediately, the ones buried deep in some CI dashboard that you might otherwise miss.
It could potentially stop those horrible Friday afternoon fire drills we all dread. That real-time CI/CD monitoring in action screencast they mentioned probably shows exactly that.
And the case study also gives a little nod to how flexible this whole MCP approach is. It mentions how you could adapt this same pattern for teams working with, say, large language models and data sets on the Hugging Face Hub.
Ah, so not just traditional code. How would that look?
Well, you'd have hub-specific tools, maybe an analyze model changes tool to understand shifts in model architecture, or a validated data set format tool.
Or generate model card to help automate documentation.
Right.
Suggest hub template for different kinds of hub submissions.
Exactly, and you'd pair those with hub-specific resources, things like hub.model cards for examples, hub.dataset formats defining standards, hub.community standards for best practices, context again.
And then LLM-specific prompts, maybe.
Hmm.
Analyze model changes, generate benchmark summary, check dataset quality.
You got it. It's the same pattern, just tailored. Tools get the domain-specific data, resources provide the domain-specific context, and prompts guide Claude through the domain-specific workflows. Very adaptable.
Okay, that makes sense. So we've got smart PR analysis, real-time CI monitoring, even extending to the hub. What was the final piece for Codecraft? The last big problem mentioned.
Communication. Bridging those information silos. Remember Emma and Jake debugging an API issue all weekend?
Oh, right, the one the backend team had already fixed on Friday, but nobody told them.
Exactly. Or design assets are finished, but the front-end team doesn't know they can use them yet. Duplicated work, missed deadlines, frustration, all because information isn't flowing.
So the final step was connecting this system to where the team actually communicates, like Slack.
Precisely. Integrating with external APIs, specifically Slack in this case, to send out intelligent, timely notifications.
Setting that up probably involves the usual Slack dance. Create an app, enable incoming webhooks, get that special URL.
Yep, the standard procedure. But the source material rightly emphasizes a huge security point here.
Let me guess. Don't commit the webhook URL.
Absolutely critical. That URL is effectively a password to post messages to your channel. It must be treated as a secret. Store it as an environment variable like Slack webhookurl on the server where your MCP service runs. Never, ever check it into Git.
Security first,
Ah,
always. Okay, so URL secured via environment variable. Then they needed a new tool.
Right. The core piece for this module, a send Slack notification tool, pretty straightforward, really. It takes a string of text the message and makes an HTTP PUST request to the Slack webhook URL, reading that URL securely from the environment.
But just sending raw text, CI failed, it isn't super helpful. How do they make the messages useful?
Ah, good point. That's where prompts come back in, but this time for formatting.
Formatting.
Yeah. They created prompts like formats a failure alert or formats a success summary. These prompts contain instructions and templates for Claude. They tell Claude how to structure the Slack message.
So like, use a red alert emoji for failures, a green check you for success, include links back to the PR or the GitHub Actions run, list the repo, the commit hash.
Exactly. All that crucial context.
Yeah.
And telling Claude to use Slack's markdown formatting in a bold, italic, and making sure the API call includes murky doing. So Slack actually renders it nicely.
This really ties everything together, doesn't it? The whole flow.
It does. It shows tools and prompts working together beautifully. Claude uses one tool, like get_sent_actions events, to grab the raw CI status data.
Okay.
Then it uses a prompt like formats a failure alert to process that raw data and turn it into a well-structured, informative Slack message string following the template.
Got it.
And finally, it uses another tool, send Slack notification, to actually deliver that polished, formatted message to the right Slack channel. Claude is the orchestrator connecting the data, the formatting rules, and the final action.
Data in, structured message out, notification sent.
And the architecture even hints at more advanced stuff. using team resources, things like team.members, Slack.channels, maybe even notification.templates
For what?
for intelligent routing. Imagine Claude figuring out, based on the failure type or the code involved, who specifically needs to see this alert, or which specific channel it should go to, maybe based on urgency or team preferences stored in those resources. It shows how all these MCP parts, tools, resources, prompts can combine for really sophisticated automation.
Seeing those example Slack messages, they show the clear CCI failure alert with all the details,
Yeah.
or the simple deployment successful confirmation makes the value really concrete.
Absolutely. And for you, the listener, this is the payoff for tackling those communication gaps. No more weekend debugging of already fixed issues. No more wondering if the build passed or the deployment went out.
It puts everyone on the same page immediately, turns
Yep.
isolated engineers into an informed, coordinated team.
Exactly.
So if we zoom out and look at the whole CodeCraft Studio system they built, how did it all come together in the end? What's the full life cycle?
Okay, let's trace it. A developer pushes code and creates a pull request.
Right.
The MCP server may be triggered manually via a prompt or automatically via a Git hook, uses tools like analyze file changes, and resources like project context to understand the PR and maybe suggest a template.
Okay, PR analysis done.
Then CI/CD pipelines run in GitHub Actions. The webhook server catches the completion event's success or failure and logs them to that file.
Events captured.
Claude, perhaps triggered by another prompt like check CI status or even running on a schedule, uses tools like get recent actions events to read the log file.
Gets the data.
It then uses a prompt like formats the failure realert or formats the success summary to interpret the event data and construct a meaningful message based on predefined templates and rules. Maybe it pulls in team info from resources for routing.
Formats the message intelligently.
Finally, it uses the Send Slack notification tool to push that formatted, context-rich message out to the relevant Slack channel.
Message sent. Team informed. Wow.
It's a complete loop, leveraging all the MCP concepts.
And through building this, CodeCraft really mastered those core concepts, didn't they?
They really did. They learned tools are the hands and ears getting data from Git, reading files, calling APIs like Slack. Resources are the brain's knowledge base, project standards, team structures, context. Prompts are the structured thought processes, standardized workflows for analysis, formatting, decision-making.
And they figured out the crucial integration patterns, how to make these pieces talk to each other, separating concerns like webhook handling from analysis, managing state simply with files, using environment variables for secrets, and letting Claude be the central orchestrator.
Plus, all those practical development lessons, handling errors gracefully, thinking about security up front, figuring out how to test systems that rely on external events. Real-world engineering.
So wrapping it all up, what's the big picture here? What did CodeCraft achieve?
Well, you saw them go from that state of chaos, messy PRs, missed CI failures, communication breakdowns, to having a much smoother, more intelligent workflow. Smart PR analysis, real-time monitoring, automated team notifications. They built more than just an MCP server. They built a system that actually helps their team focus on building product, not fighting process fires.
And that underlying philosophy seems really key. It's about empowering Claude with good data and context, using tools and resources.
Exactly. Give it the inputs it needs.
And then let Claude handle the complex reasoning and orchestration, guided by your prompts, which, counterintuitively maybe, leads to simpler, more flexible server code on your end.
It really does. You focus on providing the capabilities, Claude focuses on using them intelligently.
Okay, so here's the final thought for you, our listener, to chew on. These patterns we've explored, tools for data gathering, resources for context, prompts for guided workflows, they're incredibly versatile.
Yeah.
We saw them applied to CI/CD, PRs, even the Hugging Face Hub.
But think beyond developer workflows. Customer support. Could Claude use tools to access order databases or knowledge bases? Resources for company policies, and prompts to guide issue resolution, content moderation, data analysis, coordinating complex tasks.
The possibilities seem huge. So the question we leave you with is, looking at your own work, your own interests, where could you apply this kind of intelligent automation? What systems could you build by giving an AI like Claude the right tools, the right context, and the right guidance? What will you build next?